Hey everybody, here is the last new section of Unit 4. It is solving rational equations. We've spent the last couple lessons talking about expressions. The difference between an expression and an equation is an equal sign. You can see that right here, basically the same thing, except now we have an equal sign. Because we now have an equal sign, we'll also be able to specifically solve all the way down to a single value or two values. It says here in electrical engineering, rational equations are used to analyze circuits, particularly when dealing with resistors in parallel form. Here is our steps, shorter than before. We also have two types-ish. They're not completely two different types of equations, but we're going to deal with them differently. So our first section here is just if you have an equation that has a fraction on each side only and nothing else. There's no like random constant out here. There's just one fraction on each side and they're set equal to each other. And our second type of equation is dealing with when we have more than one fraction on a side, or there's none on this paper, but if we had one that was a fraction and then a constant like this, like that. So if this constant here didn't have a denominator, we'd worry about that one as well. In the same method, but we'd have this one. We're going to cover the first page today. And then next time, we'll do a little review practice here with these three, and then we'll go over how to do it differently when you have multiple fractions on one side. So here is our first section, how to solve rational equation, level easy. Step 1 says cross multiply to get everything in the numerator on either side of the equal sign. This only works if you only have one fraction total on each side, if you have a constant term that isn't in a fraction, or two fractions on the same side. You'll follow the next steps on the next page. So we're going to cross multiply. The way I'm always going to do that is just, I'm just going to show you how I was shown. And I was just taught to do this with little cross arrows. So you're showing that you're multiplying 2 times 4x minus 4 equal to 7 times x minus 7, because I'm multiplying this denominator to that numerator, and then this denominator to that numerator. Step 2, distribute/multiply to eliminate any parentheses you may have. You might notice that now that we have gotten rid of our denominator, this looks suspiciously like a multi-step equation, because it is. If you need to go back and look at that, that was in, actually it was in Unit 0, very beginning of our notebook. So 2 times 4x is 8x. 2 times -4 is -8. 7 times x is 7x. 7 times -7 is -49. So that's a little, so that is the end of step 2. There we go. Scoot out. Step 3, move all variables to one side, then use inverse operations to solve for x. And then in parentheses, we put the words isolated. Remember, the inverse of things, if we are multiplying, we will divide, and vice versa. If we are adding, we will subtract, and vice versa. And then if we are squaring something, we will take the square root. Let's look here. I have all my x's on either side, so I'm going to put them all on one side. I have 8 x's on the left and 7 x's on the right. You could move either one. I personally like to move the smaller one because then I won't end up with a negative number. So if I have 7 x's over here and I want it to go to the other side, it's a positive 7x. If I were to subtract it, that would give me a 0 pair and it would cancel out. Anything that happens on one side has to happen on the other side. So I have 8x minus 7x to just be 1x. I'm going to bring down what I didn't use. And then I'm going to do the inverse of what's already happening. So currently we're subtracting an 8. The opposite would be to add an 8 because that would give us a 0 pair. And this would give us -41. So that is the answer. Let's scooch it down here. There we go. Had a lot of room there. Now what we're going to do is check, I didn't put it on the steps, but we're going to check for an extraneous solution. That just means we're making sure that our answer isn't a restricted value. Remember last time we talked about restricted values? It is when you have a number that makes your denominator equal to 0. So we're going to look up here. we're going to see there's nowhere for us to even plug in an x down here, so these could never be equal to 0. So we're good to go, and this is the answer. Let's try another one. I have one fraction per side, so I'm just going to cross multiply. On the left, I have 36. On the right, I have x times 4x is 4x squared. Good, that was step 1. Step 2, distribute or multiply to eliminate any parentheses. We don't have any parentheses. So step 3, move all variables to one side and then use inverse operations to solve. All our variables are already on one side, so we're just going to do inverse operations to solve. Remember, I'm trying to isolate x. X is over here. If it'll help, I can highlight that for you. Right now, it's being multiplied by a 4, so I'm going to divide by a 4. That will cancel it out. So I have 9 equals x squared. Right now I have x squared. I'm going to undo that as well. Remember here, the inverse of x squared is to take in the square root. So square root here and there. The square root of x squared is just x. The square root of 9 is positive 3 and negative 3. So we're going to write it like this, positive or negative 3. So we have 2 answers. If you don't like this, if your brain is like, no, thank you, I don't like that, you can also do that as well. These are the same thing. It's whichever one you prefer to write. Even if you want to flop them, put the x on the left side, you can also do that. Same thing. And the last thing we're going to do is look for extraneous solutions. So we're just going to see if we accidentally have any of our restricted values as the answer. If I look up here, I would have to be able to plug into here and knock it 0. As you can see, the only way to get 0 here would be if I had actual 0, and I don't have 0, so we're good to go. Okay, try and see if you can do number 2. It's really similar to number 1. So pause and come back. Here is number 2. We should have gotten positive and negative 9. So we have 2 answers here. If you want to keep it written like this, you can. That's how I normally like to do it. Or you can split it up, same thing, whichever one your brain likes better. And remember, you have to check to see if we have any extraneous solutions, just to see if we accidentally have our restricted value as the answer, because we can't do that because it doesn't exist. Here is our denominator on this side. This one is a constant, so this one can never be 0. For this to equal to 0, it would have to actually be x equals 0, and we have 9 and negative 9, so we're good to go. Okay, we'll do number 3 together. We're going to go like that. And I end up with 5 times x minus 8 on the left is equal to 6 times x minus 1 on the right. And then we just finish multiplying. I'm actually going to pause and see if you can do it. Just want to make sure we got the beginning. So pause and then come back when you're ready. Here is number 3. You should have got negative 34. And we're always going to double check if we have an extraneous solution, meaning we accidentally picked our restricted value as our answer. If I look up here, I would need to see if I plugged in my answer, would this make my denominator equal to 0? There's nowhere to plug in over here. And over here, if I were to plug in negative 34 right there, that would give me negative 35. So I'm good to go. I think we're actually going to do, I might have lied to you earlier on accident. We're going to do one more and then we'll pause. So this is the last one. Go ahead and pause and then come back when you're ready. Okay, here is the answer. You should have gotten 12, x equals 12. Here, I cross multiplied. That got me to here to get rid of my denominators. And then remember, we're always going to distribute first to get rid of all of our parentheses. After that, we're going to do opposite operations to solve for x. Same process we did on our multi-step notes. I think it's on page 4. Here, I moved all my x's to one side. You could move to either side. I just personally like to move the smaller one because I'm always going to end up with a positive number for like my number of x's here. And then I moved over here because I didn't have any room. I was subtracting a 16, so I added a 16, and that got me to 3x equals 36. And then I just divided by 3 because I was multiplying by 3, and that got me 12. And lastly, I'm going to double check to make sure I didn't accidentally pick my restricted value for my answer, because that's not possible. So I would just plug it in here and see, could this give me 0 on accident? 12 plus 4 is 16, so we're good there. And then 12 minus 2 would be 10, so we're good there as well. Cool, awesome. Hope this helps. Bye.